This is R.D. Sharma solution. We are taking class 12, chapter 19. Exercise is 19.28 of indefinite integrals. Cos x under root 4 minus sine square x. So by the virtue of differentiation, we know that sine x, if differentiated, can give you cos x. And since we are doing the exercise or the questions of certain formula, that formula can be applied. So if we take t equals to sine x, or assume t equals to sine x, and we differentiate both the sides, dt by dx will be equal to d by dx of sine x, that will give you cos x. So dt will be equal to cos x into dx. And what do you see in the question? Cos x dx is already there, and we can replace wherever sine x is there by t. So what are we going to get after this substitution or assumption? In place of cos x dx, I am writing dt, and inside the root, 4 can be written as 2 square and sine square x can be written as t square. And you already know and you are aware of this formula or this result. Under root a square minus x square is given by x by 2 under root of a square minus x square. Then we have plus a square by 2 sine inverse x by a plus a constant of integration. A we are going to take as 2 and x as t because we assume t. We are going to replace it in near future, but right now we will use these to put in the formula. Let's go ahead and put t by 2. A square minus x square will be 4 minus t square. A square by 2, a is 2 square, 2 square by 2 is 2 only. Sine inverse x was t and a is 2. So t by 2 we get. And then we have t equals to sine x. So replace wherever you get t as sine x. So this will be sine x divided by 2 under root of 4 minus, what is t? Sine x originally, 4 minus sine square x plus 2 sine inverse t by 2. What is t? Again sine x. Sine x divided by 2. Just add a constant of integration. T equals sine x. We replaced it. And after this replacement, we get this expression, which is the final result. Now how we are going to go about it or write it is in front of you. This is for those who want reference. In the same way, we can see that e raise x will always give you e raise x. So if we take e raise x as t and differentiate both the sides, e raise x will be e raise x and t differentiation will be dt by dx. So you can write e raise x as dt by dx, and then you can get a dt by multiplying this dx on the left side. So dt will be equal to e raise x dx. So these both are known to us now, or we are ready for the replacement. E raise dx I am replacing by dt. Inside the root, since e raise x is only t, but e raise 2x will be what? If you make t square, it will be e raise 2x. So e raise 2x can be written as t square. And for 1, I just swapped these two terms and made it as a square. So this integration will be like this because t, of course, is now what we have assumed. So it will be t square plus 1 square. You can write it as 1 square plus t square also. Now we know the formula. We are aware of the formula of a square plus x square or x square plus a square under root integration. It is x by 2 multiplied by under root a square plus x square plus half ln x plus under root ln is log base e. X plus under root x square plus a square. There is a slight mistake which I am going to just fix, but right now it's just x plus under root x square plus a square. Take x as t, a as 1 and replace it here. So t by 2 under root 1 square plus t square plus half ln is log base e modulus t plus under root x square plus a square. As I told you, I am going to fix it just now. It's just x plus under root x square plus a square only. So t plus under root t square plus a square, which is 1 square. Now if you remember, t was e raise x we assumed earlier. So now replacing t by e raise x, it will be e raise x by 2 under root e raised to x plus 1 plus half ln log base e modulus e raised x plus under root same content e raised to x plus 1 and plus a constant of integration. This is your final result. And for the reference, I'm showing it to you. You can solve it by using, and one more important thing is the formula. Under root 9 minus x square. Now this is a straightforward formula only. We have to apply the formula of a square minus x square as we see here, because 9 can be written as 3 square and x square is already x square. So under root a square minus x square dx will be equal to x by 2 under root of a square minus x square and a square by 2 and sine inverse x by a. We have no assumption, no substitution, directly x as x and a as 3 as given in the question. Now I am putting this all in equation number 1. X to be replaced by x and a to be replaced by 3. So x by 2 under root same thing 9 minus x square plus a square by 2 which is 3 square which is 9 by 2. So 9 by 2 we have sine inverse x by a, that is x divided by 3 plus a constant of integration. This is your final result. Okay, this can be very clear when you usually do it by yourself. Under root 16x square plus 25. Now there is a new concept which I am going to highlight here. If you take this 16x as 4x whole square, it will be 16x square. 25 can be written as 5 square. Now x square plus a square formula is known to us. But the problem comes here is what to do with this 4 which is preceding x or which is along with x as a coefficient. So we need to get rid of this. Otherwise people will say take 4x as x and 5 as a. But that's not the case. So in order to get rid of this 16, I'll take 16 common. And when you take anything common, it is just that division divided by everything which is inside. So 16 if we take common, x square by 25 by 16 will come. 25 by 16 can be written as 5 by 4 whole square. 5 5s are 25, 4 4s are 16. So now we can change this equation or modify this equation according to us in this way, that this under root 16 which has come, actually it's under root a into b form. So under root a, I am taking under root a as under root 16, under root b as under root x square plus 5 by 4 whole square. You can always take this outside. Under root 16 or root of 16 is 4. So this 4 will come outside even if you take the integration. So we'll talk about this 4 in a bit. We'll deal with this x square plus 5 by 4 whole square, which is actually the formula x square plus a square. So let me revise you or made you recall this equation which is x by 2 and in under root a square x square plus a square. Remember, this is not under root x square plus a square, it is the integration of under root x square plus a square, right? This is the integration of under root a square plus x square plus a square or a square plus x square, whichever way you call it. So x is equal to x we are going to take and a will be taken as 5 by 4. I am putting this in the formula of integration of under root x square plus a square dx. X by 2 under root x square plus a square, let's write it just like that. X square a is 5 by 4 whole square for us. Plus a square by 2, what is a? And a square 5 by 4 whole square divided by 2. So 25 by 16 and there is a 2 also. So we need to multiply this 16 by 2 in the denominator. So we get 25 by 32. 32 ln modulus x plus under root x square plus a square. A will be 5 by 4 whole square in this case plus a constant of integration. Now 4 was already there. So let's multiply this 4 with each term. 4 into x by 2 will give you 2x. Under root x square plus 5 by 4 whole square, you can write it as 25 by 16. 25 by 32 will also be multiplied by 4. So 8 4s are 32. It will be 25 by 8. ln modulus of x plus x square plus 25 by 16 again plus a constant of integration. This is your answer. And this has come from integration, okay? I am talking always about integration of this particular term. Let me write it also. It's under root 16x square plus 25 integration of dx with respect to dx. So this is the reference for you. You can use it. Under root 4x square minus 5. Now we need to get rid of this 4 in order to apply the formula directly. So we'll take 4 common from here. And taking common means dividing that term with whatever is inside. So x square minus 5 by 4 will come. Now assume this to be under root a b. So under root a into under root b we can write. So we can take this under root 4 outside or as a separate term, and what remains is under root x square minus 5 by 4. Under root 4 is directly 2, or square root of 4 is 2, so we will use it just now. We are going to deal with under root x square minus 5 by 4. 5 by 4 can be made as a perfect square. So 2 integration of x square minus 5 by 4 can be written as root 5 by 2 whole square, which will give you 5 by 4 ultimately. But we need to make it look alike the formula so that we can apply the formula. So root 5 by 2 whole square is a square actually. Now let me write the formula here somewhat below so that you can see when I apply it. It's x by 2 under root x square minus a square minus a square by 2 ln log base e x plus under root x square minus a square plus a constant of integration. This 2 we are going to deal just now. In place of x, put x. In place of a, write root 5 by 2. In this formula which I showed you just down below. X by 2 under root x square minus, what is a? Root 5 by 2 whole square, which is 5 by 4 only. Then minus a square by 2. What is a square? Root 5 by 2 whole square will again give you 5 by 4 only. And there is a 2 also. So we have 5 by 8. And ln log base e x plus under root x square minus 5 by 4 plus a constant of integration. We have already arrived at the answer, but there is just a bit. I told you 2 I'm going to introduce just now. 2 into x by 2 will be x only. Under root x square minus 5 by 4, 2 will be multiplied by 5 by 8 also. So 2 4s are 8. It will give you 5 by 4. ln modulus of x plus under root x square minus 5 by 4 and then a constant of integration. So this is ultimately integration of 4x square minus 5 under root with respect to dx. Alright. So let me show you the reference also. It's important for those who are doing bad themselves. This we'll take later. Thank you so much. Have a good one.